Here we have a pre-calculus question on polynomials. Okay, let's go over the question. In order to factor the polynomial function p of x equals to 3x to the third power negative 2x to the second power negative 19x and negative 6, a student determined that the function has a 0 of x equals to 3. He then wrote the polynomial as a product of a linear factor and a quadratic factor as shown below, where a, b, and c belongs to I, that is integers. Okay, the factored form of the given polynomial is p of x equals to x positive a times ax square positive x positive c. So which of the following rows shows the correct values for a and b? So our aim is to get the values of a and b. Okay, so here the student determined the function as 0 of x equals to 3. Okay, so the factor, the linear factor we get corresponding to this 0 x equals to 3 will represent this x positive a. So first let's find the linear factor corresponding to this 0 x equals to 3. So to get the linear factor corresponding to this x equals to 3, I have to make the right side 0. For that, I have to subtract 3 from both sides. This positive 3, negative 3 will cancel out. I get x negative 3 equals to 0. So this is a linear factor corresponding to the given 0 x equals to 3. So in the factored form of the polynomial, the linear factor actually is x positive a. So the second one is quadratic polynomial. Okay, so this linear factor x positive a can be replaced by x negative 3. Then I'll be getting p of x equals to x negative 3 times 3x square positive bx positive c. Okay, comparing x positive a over here, x negative 3 over here, what do we get for a? We get a because at the place of a over here, we get negative 3. So the value of a is negative 3. So when I look at the 4 rows, so only in row A and row B, we get a is for negative 3. So we can reject so row C and row D because in these two rows, we get a is equal to 3. Okay, now, so here we have the factored form of polynomial over here. So when I multiply the constant term of the first factor negative 3 and constant term of the second factor positive c, I'll be getting negative 3c. So this negative 3c must be equal to the constant term in the polynomial given over here. So that is negative 6. So negative 3c equals to negative 6. So to solve for c, I have to divide both sides by negative 3. So this negative 3 will cancel out. And negative will cancel out. 3 goes into 3 one time, 3 goes into 6 twice. So I get c equals to 12. Sorry, c is equal to 2. Okay, now, so what I can do is I can plug in the value of c over here. So then I'll be getting x negative 3 times 3x square positive bx. And for c, we can plug in 2. Okay, now what I'm going to do is I'm going to multiply these two factors so that I can compare the coefficients of like terms over here and the result of the product, and I can get the value of b. Okay, let's multiply these two factors. For that, we have to distribute this x to each term, the second factor. So x times 3x square will be 3x to the third power, x times bx will be positive bx square, and x times 2 will be positive 2x. And now I can distribute negative 3 to 3x square. It will be negative 9x square. Negative 3 times positive bx will be negative 3bx. And negative 3 times 2 will be negative 6. Okay, here p of x equals to 3x cubed. And we can write the x square terms together. Here we have bx square. Here we have negative 9x square. So positive bx square, negative 9x square. And then we can write x terms. So positive 2x and negative 3bx. And at last we can write the constant term. So p of x equals to 3x to the third power. So I can factor x square out from these two terms. So if I factor x square out, I have I have only b left in the first term, and I have negative 9 left in the second term. So b negative 9 times x square. And here I can factor x out. So if I factor x out, I have 2 left in the first term, and negative 3b left in the second term times x negative 6. Okay, now so we just got the polynomial px over here, and this polynomial are same. So we can compare the coefficients of like terms. Our aim is to find the value of b. So let's take the coefficient of x over here. That is 2 negative 3b. Okay, so what is the coefficient of x over here in the given polynomial? It's negative 19. So since both the polynomials represent the same, so the coefficients of like terms must be equal. The coefficient of x over here, the coefficient of x over here must be equal. Okay, now we have to solve for b in this equation. So for that, I subtract 2 from both sides. So positive to negative will cancel out. I get negative 3b equals to negative 21. Okay, now in this equation, I'm going to divide both sides by negative 3. So negative 3b over negative 3 equals to negative 21 over negative 3. So this negative 3 will cancel out. Negative will cancel. 3 goes into 3 one times, and 3 goes into 21 7 times. So I get b is equal to 7. Already I got the value of a, so I got a is equal to negative 3. So a equals to negative 3, b equals to 7. So we find a equals to negative 3 and b is equal to 7 in row b. So row a is also incorrect. So the correct answer choice for this question is row B.